All right. So keeping going with our game, as I'd like to think of these things as kind of like giving a dog medicine by hiding their medicine in their food. So we're writing this video gamey thing, and then we keep introducing these programming concepts under the hood, and you almost don't notice until it's like, oh, well, now I know what inheritance is and abstract classes and stuff like that. We see it through examples. All right. So last time we had written this player class or finished the player class where we're deciding to keep track of 4 fields. We made all these guys private, so they're only accessible inside of the class called player. We re-emphasized last class about the idea that keep in mind that a private field is accessible anywhere when you are inside of a class called player, even if you're referencing another instance of player other than this. Okay, it's an important little thing that every now and then you'll there's a reason why that makes sense. It's the same logical reason as it makes sense in general, but it's not only in a particular instance. It's across the board anywhere inside this class. So our constructor set up the name. Then we kind of did this hack job creating the right size dice to give our random numbers. In hindsight, maybe we would have just used a random number generator to do that, but whatever, it works. So we randomly rolled hit points, strength, and armor class. We also taught players. Notice this is public, so you can think of these like abilities or behaviors. We taught a player how to report whether or not they're dead. So we can ask an instance of player, are you dead? By calling their is dead function. Notice this guy is public, so we can access this outside of the player class, which I think we do inside of Arena. As we're going through here, we ask the question, is whoever was just hit, is he dead? if he took too much damage and he's keeled over, we want to get out of Dodge here. Okay. We also taught a player how to take damage. So they take in an amount of damage. They modify their internal private field hit points to be its new version with fewer hit points than it used to be, because we cannot access this .hp outside of this class. We gave ourselves a getter for armor class. We gave ourselves a getter for the name. Getters give us read-only access to private fields. And then we taught players how to display themselves. Make that look however you want it to look. All right. So if you go back to driver, we look at main. I've kind of mentioned all programs begin and end with main. So main is kind of like the conductor or the director of our play. So he calls all the shots of what starts. And then, if we tell the constructor of player, we call the constructor of player here. If that guy goes and calls 10 other things, that's where the rabbit hole goes. But at some point, we end up making our way back to main. All right. So what do we do in main? We create a player. We create another player, whatever that means. We can follow the down the rabbit hole and look at the constructor for players here. We know these are constructors because we have the opening and closing parentheses. We also see them after the new keyword. We also see that it's named the same thing as the class name. So it's a constructor, not a method. Then we have this thing called an arena. So we invented another new variable type, another object last time called arena, with the idea that an arena is where we throw 2 players into it and tell them to fight to the death. All right, so we built our arena. An arena keeps track of a couple of players. It also globally has a D20 die, which we'll put into some use here moving forward. I think we've used it to roll for your attack roll so far, but whatever. All right, so we're keeping track of a couple of private fields. So again, fields should probably always be private and then only loosen the reins if it makes sense. Okay, but it's rarely going to make sense for you to have non-private fields. Non-private or protected fields. Well, when we get to inheritance, we'll talk about making these guys protected and what that means. We look at our constructor for arena. Arenas are built with 2 players, like we throw a couple of boxers into the ring. All right. We set up all the right things. We build our instance of our D20 dice. We have the ability, a public ability, where we can tell the arena to start the fight. You see that from Maine. We do that. After we build the arena, we tell the arena to go ahead and start the fight. What does start fight do? Well, we go ahead and create local variables for the current attacker and the current defender. We just specify that player one or P1 is the current attacker. So we could do a little competition in Dungeons and Dragons. It's usually called roll for initiative to see who goes first and that kind of stuff. But we just randomly said, player one, you're up. Okay, you're taking swings. Player two, you're trying to block them, and then we flip flop. All right. So we have this loop here. So this is an example of when we might use an infinite loop. Infinite loops. Some older books might say, oh, it's bad to use infinite loops, just like they'll also say global variables are bad. There's a right time and place for stuff. In this particular case, an infinite loop made sense because we knew that only circumstantially will we want to get out of this loop. So it's easier to do that at the point in time where we might break out of this loop using the break command or return, depending on if we have more stuff to do or if we're still cooking. But effectively, we're going to say, look, we're going to keep spinning forever. This while loop will never end on its own. Something inside the while loop might end up short-circuiting this and having us bail. Okay? But it's not going to bail because of the Boolean expression here. Because true is always going to be true. We don't get to redefine it. All right, we start off, we tell both players to display their current state. We make an attack roll, so we roll the D20. We check to see if that attack roll was at least as big as the defender's armor class. If it was, if we rolled their armor class or higher, that means we hit. So we're in this if statement if we have hit the defender. We hit the defender, we're going to go ahead and roll a four-sided die to get our damage. We just invented that. We just decided it's a D4. We could wrap their strength into it or something like that if we wanted to. Then we ask the defender to take that damage, whoever the defender currently is, because we flip-flop them at the end. So initially, P1 is the attacker, P2 is the defender. Then after the defender has taken some damage, we check on him. So, dude, are you dead? If you're dead, we're going to say that the attacker has won the fight because he's the guy who just hit the defender and the defender's now dead. All right, so we call the winner and then we bail out of this entire function, which breaks the infinite loop because the function is over. We're calling the return statement. I think the question came up last time. What if we were going to do stuff following the loop? After the loop, but before the end of the method. If we had stuff here, instead of returning here, we would say break. And break would get us out of the loop, but keep us in the function. All right. In this case, we don't have anything. This is the end of the infinite loop right here. Okay, we don't have anything inside after the loop, so we can go ahead and return. Just keep in mind that it's not that one is better or worse than the other. You might even say, okay, well, if I might put some stuff down there later, you could choose to just break out of the loop and then just have the method end a natural, die naturally. Kind of up to you. All right. So that's what happens in Arena. If the person did not die, which means that either we didn't get into this if statement or we missed initially where the attacker didn't actually hit the defender, in which case the defender would not have been any worse for wear. We get into this else saying, hey, he swings and misses. We ask the question if he really missed badly. If he rolled a 1 in his attack roll, we make fun of him a little bit. Otherwise, right here is where we swap the attacker and the defender. The person who used to be the attacker now becomes the defender. The person who used to be the defender now becomes the attacker. We have to use a extra variable here to kind of preserve one of the values so we don't overwrite them. All right, so that's where we do the swap. So then the next time through up the loop, player one and player two are still the same people as they used to be. We have not changed those values, but current defender and current attacker are different people now. All right, we've swapped them. All right, so that is the current state of our game. Questions about that? Okay. Now, we're not going to spend too much time coming up with little idiosyncrasies of, oh, do we wrap strength into their attack or into their damage or whatever. You can certainly do that in your version of the game. We want to think about the more programming type things. So right now, we're calling everybody a player. Okay, just like in real life, we are all humans, but each one of us has things that are unique to us that might further categorize us, right? So, for example, I'm a fat guy, right? That puts me into a different category. We can keep going down the path, right? All right. So, in any case, we either have to add fields to the idea of a human, where we have height and weight and all this stuff, or we possibly subdivide that into maybe genders, then into small, medium, large, whatever it is. All right, so let's look at that. If we think about this in terms of like a game like Dungeons and Dragons, you would not have just normal players. Everybody picks a class, not to be confused with the object-oriented version of a class, but they would say, "Oh, I'm a fighter, or I'm a wizard, or I'm a monk, or whatever it is. I'm a ranger." Okay, so we have these other classes. So for right now, let's just create two simple things. We're going to have a fighter, and then we're going to have a wizard. All right, with the idea of that fighters swing with swords, wizards attack with magic, something along those lines. All right, so we're going to create a couple of classes here. So we're going to go ahead and create a fighter class. I'll create a new file. All right, this will be, I'll make it public class fighter, even though just class fighter is good enough for us because that gives us package level security. Something I'm going to encourage you to do for a little bit is always put either public, private, or protected in front of stuff for now, so that you're forcing yourself to make that decision of what kind of access do we need to have, as opposed to relying on what the default behavior is. This kind of goes back to when we talked about primitive types and what the default values might be. Like when we define an int, the default value is 0 typically. Our newer languages will not let you use a new variable, an int, if you have not actually put a value in it itself. Okay, so it protects you from yourself. You can't use a variable that hasn't already been initialized with a value other than its default value. But some older languages like C++ and C, these guys will say, hey, you want to define a variable and you don't want to put anything in it, we'll let you use it, whatever the default value is, and that's not good programming practice, even if you know what the default value is and you're okay with that for starting to use the variable. All right, so we're going to say public class fighter. Now, I'm also going to create my wizard class. We'll just leave them fairly empty for right now. So this guy will be wizard.java. We'll say public class wizard, like that. I'll go ahead and save everything, make sure we're still good. All right, so now what we need to do, let me go ahead and draw a picture here. We're going to be talking about this here in a few minutes. This. Well, draw some shapes. All right, so we imagine that we have this thing called player that we've already written. Now we have two new things. We have a fighter and we have a wizard. Now, let me ask you this. We're going to say types of players. We've decided fighter and we've decided wizard. All right. Now, what differentiates a fighter from a standard player? What might we add to our player? Let me just bring up player here. Right now, a player, the information we're keeping track of a player is their name, their hit points, their strength, and their armor class. What are the aspects of a fighter that differentiates themselves from a generic player? The follow-up is going to be what are the aspects of a wizard that differentiates themselves from this guy? Good.
So fighter with more strength than like your average player, and it also would have, I think, higher armor class, but a wizard would have more range or spells, and but also would have the lower attack because it uses range instead of physical.
Okay. So if we keep it simple, so he pointed out is that typically a fighter might be stronger. So they might get some sort of enhancement to their strength, right? Um, they might also be tougher. So they might be able to, take a punch a little bit better, where, because they're probably wearing some kind of heavier armor or whatever, where a wizard might be standing there in their bathrobe, effectively, probably going to have lower armor, probably going to have lower strength if we end up incorporating that into our attack. And he mentioned that they're kind of a range person, so they're probably casting spells. So instead of swinging a sword, they're sitting there casting some spell on you, and that's how they deal the damage. So a lot of times, what you might say is that a wizard might put out more damage on a per shot basis. But really, he's got to kill him quick because he's not going to be real sturdy. All right. So we start differentiating them a little bit from there. All right. So let's start with fighter. All right. So we are going to have a constructor for fighter. So constructors have the same name as the class name. Now, ultimately, a fighter, we want to have them built in terms of a player. We don't want to reinvent the wheel. We don't want to have this idea of this generic player over here that we never actually create instances of. And instead, we just make a better one with a fighter or a better one with a wizard. We want to say, hey, this fighter has everything that a player has, but then he further differentiates himself. All right. So we're going to say that our class fighter extends player. So let's kind of get our notes what the extends keyword does. Extends is used after the class name during the implementation of the class so that we can make this class a further, call it enhancement of an existing class. That is the class being extended. All right. And this deals with inheritance and object-oriented languages. All right. So going back to our code here, we're saying a fighter extends player. That means a fighter starts off with everything that a player is. So if we go back and look at player, in order to build a player, the bare bones player, what do we need? Well, to build one, we're looking at the constructor right here, right? Here's our constructor for player. We need one thing to build a player. The player's internals do the rest for us, right? We need a name. Okay. So when we build a fighter to build his playerness, right? He's going to have to create his inner player, if you will. He's going to need a name. So that means when we're defining our fighter here, Java, capital S, we're going to have to take in the name. Now, we ultimately want to build our parent, build our playerness, the person we extend. We want to build him in terms of ourselves. So the very first thing we need to do is we have to call our parents constructor so we can build our base. Called baseline. I don't know, good enough. All right. So now we have to introduce another keyword. What does the this keyword do? Tell me about the this keyword. Okay, so this is how an object refers to itself within itself, right? We have another keyword called super. Super is how an object refers to the instance of its parent or within itself. All right. So now we know how to talk about ourselves, this, and we know how to talk about the thing we're built in terms of. Super. Before I go any further, if I'm inside a player, who is super? Does player extend anything? Yeah, nothing that we see, right? He said, we don't see the extends keyword. This goes back to one of the things I mentioned why I use older languages initially. Player does extend something. There's an invisible thing here. Extends, what do you think player extends? Object. We didn't write that guy. Object came with the Java programming language. All object-oriented languages have some top-level thing, top-level object. Okay, sometimes it's a capital O, sometimes it's a lowercase o, but that's your baseline object. Everything that's in this guy. So if I go to actually here, we'll just do Java object class. That should get us to the right place. All right. And we've seen this syntax. Let me make this a little bit bigger. We've seen this syntax before. I mentioned this before, this thing called JavaDoc, this format. All right. So this is something that I would argue is probably the most powerful aspect of Java. I mean, Java is a good language. Nothing wrong with it, but it has its pros and cons, especially when it comes to performance for like games or something like that. You probably wouldn't write a modern video game in Java because it runs inside of something called a virtual machine. In the early days of Java, its selling point was something along the lines of that Java was platform independent. You know, you write your program one time, it'll run on any computer out there as long as they had the Java virtual machine. Okay. In the older days, so if you have like a C++ program, this goes back to what we had previously talked about. If you have a C++ program and you wrote a video game, let's say, and it runs on Windows, and you want that program to now run on the Mac or run on Linux, you have to potentially rewrite large aspects of the program. Typically, it's called porting. You got to port your software over to this other platform. At the very least, when we talked about compilers, we talked about compilers convert between a high-level language and a low-level language. And compilers need to know about two different things in order to do their job. What are the two things that a compiler needs to know about besides knowing about the language you want to compile? What are the two things that a compiler needs to know about in order to output an executable on the platform you want? Go ahead. Yeah. So it needs to know what operating system you're targeting. If you remember back to our original Hello World program, when we looked at the assembly Hello World for the Linux operating system, so it made system calls, it referenced system calls for Linux like syswrite, sysexit, those things. It made those references and had to know the right code to trigger the operating system to call those certain system calls. The other thing it needs to know about is what kind of CPU you're using, the architecture. Every CPU unique architecture has its own assembly language. If you're running an Intel-based processor or an AMD-based processor, your assembly language associated with your CPU is some superset of original x86 Intel architecture. All right, that's why sometimes you'll see a piece of software maybe requires a minimum processor. A lot of times the minimum processor a piece of software requires is not because of the speed. It might be. You might be like, look, you're not going to run this on an old DX2. Right? You need a Core i5, Series 6 or something. But it could be speed, but more than likely, from a functionality perspective, that processor needs to know about all the magic tricks that software is referencing. Okay. And if you go back to a processor from 20 years ago, it doesn't know about all the specialized stuff that modern architectures can do. So it might be making an assembly call to something that doesn't exist on a processor if it's too old. All right. So most of our modern software is based, if it's running on Windows, Intel-based processor. AMD's architecturally compatible with Intel. They have a couple of things that they say we're better at this or whatever, but they're architecturally equivalent, or at least very close. But in any case, we need to know about those two things. If you're running on a Mac, this was true years ago, then it wasn't true for a few minutes, and now it's true again. Years ago, Macs ran on a processor called the PowerPC processor, which was made by IBM. So if you were a Mac user in the PowerPC or the G2, G3, G4 years, those were all IBM-based processors based on what's called a reduced instruction set. So they kind of had a smaller assembly language, fewer magic tricks that did more stuff per magic trick. Those didn't work out that great in the early days. So does that mean that we need large instruction sets in order for computers to be powerful? How many of you have a smartphone? Do you think your smartphone runs an Intel compatible processor? Anybody know what architecture your smartphone is running? If it's an Android phone, what's the architecture? Not x86, it's ARM, ARM. Okay. ARM is a reduced instruction set architecture. So instead of it being x86 Intel assembly, it's ARM assembly. They do very similar things, but it's a different architecture. Therefore, the compiler, if you're writing something for your Android phone that's running probably some flavor of the Snapdragon processor or something, it has to know that you're targeting Android and that you're targeting an ARM processor. So for a long time, Apple ran PowerPC processors, which were reduced instruction set. IBM had a problem producing them. I mean, Apple's always been expensive, but it used to be less profitable for them to be expensive because they had a high failure rate for their processors. So then Apple they did this twice. two pretty gigantic risks. I mean, you can love Apple or hate Apple, but man, they almost failed as a company a couple different times. So they switched from PowerPC based architecture to Intel. Intel was they're the big makers of the chips. At the time of this, we were probably dealing with some level of the Pentium processors. I'm not sure. It was before the Core processors, but some Intel Pentium level processor. When they switched to that, we all of a sudden have a problem. And it relates to what we just talked about with compilers. All your software that was running on your Mac yesterday, if you bought a new Mac today, yesterday's Mac had the PowerPC processor in it. You go and buy a brand new one today, it has an Intel processor in it. All the software you've bought up to this point that you're going to go and reinstall on your new Mac won't work. Why? Because it was compiled for the Mac operating system with the PowerPC architecture. So now you're trying to put that software onto a computer running the Mac operating system, but the Intel architecture. So all that software needs to be recompiled at the very least, probably updated as well, but at the very least recompiled. How did Apple get around this? This is giving us a little bit of a history lesson, but it's a lesson very related to what we're talking about here. How did Apple get around this day one that they started shipping their computers with Intel processors? How many of you have ever heard of something called a virtual machine? Now, these were not popular back then, but when Apple first came out with their Intel processors, their operating system shipped with a piece of software called the Blue Box. This was during the time period of Mac OS 9, I think was when they did that first switchover. So OS 9 shipped with a piece of software running on it called the Blue Box. And what the Blue Box is it allowed you to run Mac OS 9 applications for PowerPC architecture on your Intel computer. But it was doing that in software. So all those applications ran way slower. Maybe you don't notice too much if it's Microsoft Word, but if you were playing any sort of game or things that required more performance, it was not a good experience. For those of you who use virtual machines today, I use a lot of virtual machines. I carry around one computer, but on a daily basis, I might run Linux or Windows or whatever, hence my RAM I get on these machines and number of cores. But if you are, so what I do is I run a virtual machine. I use Parallels on here. There's kind of competition for Mac. Parallels is one VM. The other one is VMware Fusion. I like Parallels better, but they're the same crap. But in any case, I run that allows it to pretend to be a different architecture so I can run different operating systems and things like that in case I need access to certain software without having to carry around more than one computer. All right. So Apple shipped with this Blue Box software that allowed you to run your software that used to work yesterday, but more slowly because now it's going through this virtual machine rather than running directly on your hardware. It took probably, I'm just recollecting this, something like 6 months or so before a good chunk of the mainstream software was mapped over to run natively on the Intel processors for Mac OS. So Apple survived that, but that seemed like it was a pretty big risk. And without losing a beat, about a year later or so, it really wasn't that long later. Maybe it was 2 or 3 years. It's so long ago now, but Apple decided to make a different shift. They went to, actually, you know what? OS 9 was not OS X. It was the first version of OS X when they came out with the Intel stuff. Because what had happened is they came out with OS X running on PowerPC first. Then they switched it to Intel, so all your stuff broke. Well, then Apple went and OS X, whether it's OS 10 or X stands for the X in Unix, who knows? But OS 10 for Mac was not an upgrade to OS 9. It was a whole different operating system. with different system calls and things like that. It was based on the Unix operating system. So now all that software that had already been ported over to now run on Intel is now compiled for the wrong operating system. It's compiled for the PowerPC version of Intel or of OS X rather than the Intel version. Apple survived that as well. I mean, these were rocky times for Apple. They took some pretty big risks. I mean, these were the correct technical decisions. At the time, Intel was the superior processor to PowerPC. It was the correct choice, but you're alienating. I mean, Apple's has this core group of followers, right? Okay, and you alienated all of them. And historically, Apple users are not your geekiest users. Apple users tend to be your it just works users. That type of approach. So they couldn't really bob and weave with these changes very easily. What's funny though is must be about 6 years ago now, 5 years ago, whatever Apple came out with their M1 processor. Apple has now jumped off the Intel bandwagon again, back to now they bought a processor company, so now Apple has their own silicon. So now like this machine's their M4 Max, their newest processor. That's back to a reduced instruction set architecture. Now I teach the graduate level architecture classes. Typically, Professor Liao teaches your computer organization that you'll have next semester, what's under the hood. But I could promise you that at least for today, Apple's architecture is significantly superior to Intel's, purely from a technical perspective. These are strong processors. But Apple had to do the same thing again. In this case, the consumer wasn't really impacted because Apple built into the architecture the ability for it to map in real time. So ultimately, to get your maximum performance, you want to have your software recompiled for Apple's architecture and their operating system. But you probably didn't notice a significant dip in processing or feel in your operating system when your M1, M2, whatever processor was running your Intel-based software, mapping it in hardware in real time. Felt pretty good. It was something called Rosetta that Apple came out with to do that mapping. It's not that they probably couldn't have done it years and years ago. We just didn't have the processors with the horsepower to be able to fake it. But kind of this interesting twist that's happened over the years. And so now you have Intel kind of playing catch up with Apple for the architecture, which is good for us, right? I mean, Intel's not a bunch of slouches. They'll figure it out and they'll probably catch up, take the lead. Apple ones up some, and we all win. Go ahead.
So what year was this, that you're talking about?
I mean, let's see. It would have been, well, what, when we went to M1?
Yeah,
Apple's own processors again? I want to say something like 2015, 2016
okay.
is when the M1 processor first came out.
The X1, that was like back in like
Mac OS X, that had to be early 2000s, I think. I don't know the exact year, but that wasn't like yesterday. Some of this happened probably before most of you were born. But these were big deals. And in the computer science community, it was a very interesting thing to unpack technically, right? Forget about the end user experience. We're computer scientists. We're the ultimate end users, right? We can bob and weave and figure it out or whatever, but kind of a interesting backstory. But in any case, architecture and operating system are important when it comes to these languages. I know that was kind of a dip or whatever, but we were talking about kind of the value of Java as a programming language, even though today, I mean, I've kind of mentioned that all languages are the same. They all are solving the same problem. They all have facilities for remembering stuff, asking questions, and repetition. Java is just as good as any other language. I would argue that Java's greatest strength or strengths. If I think I would point out two things that Java is very, very good at that makes it an ideal language for many things. One is it's platform independent, which means you can write your software one time and it will run on any computer that supports the Java virtual machine. Because now when you compile using the Java compiler, you're not targeting Intel or M1 processor architecture or Snapdragon, whatever it is. The architecture you're targeting is the Java virtual machine. Each Java virtual machine, so Java virtual machine was written for Mac, it was written for Windows, it was written for Linux. Each one of those does the mapping from the Java virtual machine assembly language to Intel assembly or M1 architecture assembly or ARM assembly for Snapdragon, so on and so forth. So it's the virtual machine that they ported 3, 4, 5 times so that you as the developer don't have to port your software. Now, back in the early days of Java, this sounded good. Okay, it sounded good. I guess this gets the geeky version of political, maybe. Back then, the complaint was that, oh, Windows and Intel-based computers have this software, which we should have, and have this software, which we should have as Mac users. A lot of it was video games, but some of it was business software or whatever. And it tended to be that the Mac users were significantly noisier than their population would suggest they could be. Okay, so it sounded like a big problem, but really didn't impact a significant amount of users. But it was enough of a problem, and they were related enough to the makers of Java, which was Sun Microsystems at the time, later became Oracle, that they said, oh, well, we need to create this language that alleviates this issue where now people can write their software one time, and it doesn't matter whether you're a Mac or a Windows user. It'll run, no problem. Okay, but the part they left out is not all pieces of software are created equal. Right? If you're running Microsoft Word, you could write Microsoft Word in Java, no problem. It's fast enough for that. But if you're playing a video game, now it's a problem. Because any way you cut it, every single Java program you're running is going through a Java virtual machine that is mapping it at the very least from one low-level language to another low-level language. There is a translation that is occurring, which does take time. So Java was really, really, really good for a very specific subset of software applications. They actually have a technology that isn't really talked about that much anymore, but still is used fairly heavily, called Java applets. Anybody in here know what an applet is? You've probably experienced one before. The best example of an applet running from a profitability perspective is for professional investment platforms. Like you go to, TD Ameritrade or E-Trade or any of these, Charles Schwab, any of these websites for, managing, buying and selling stocks. And you got these people who are like day traders. Well, day traders who are moving lots and lots and lots of money on a daily basis, they're using software that gives them lots of different views and access and things like that to do stuff more so than just a web page that says, I want to buy 8 shares of X. Those platforms launch out of a web page as a Java applet. Java is plenty fast for those kinds of applications, even real-time applications. It's not that Java's slow. It's just you're not going to accomplish the video game stuff through Java. And that was a promise that Java kind of originally made, that it was going to fix the video game problem, which was probably what the loudest Mac users were complaining about, is game X, Y, or Z didn't run on my Mac. When most of you in here who are PC gamers know that if you're a PC gamer, you get a Windows machine. Period. There's not an argument, right? Okay. I can only game on my Mac because I play World of Warcraft, and Blizzard Activision happens to port most of their games over to Mac. Otherwise, I have my PC at home for all that stuff. Go ahead.
So what about different consoles? Like, do they have their own, like, operations?
Most of the consoles are based, at least up till PS5. I think PS5 might use its own kind of architecture, but most of them have been based on Intel architecture for a while. And then usually some sort of specialized version of either NVIDIA or ATI graphics processing. We've kind of moved away from it for a long time. What you had with the video game consoles was kind of a standardization. There were faster computers out there than those, but now you have a situation where people who are writing software can optimize it exactly for PS4 or exactly for Xbox One, whatever, whatever the version of the thing was. So you knew you were going to get a consistent performance across all of those consoles because you built the game to target that console. Well, now you have a couple of different versions of each console. You have like the Pro, I think PS5 just came out with a Pro version that but the money doesn't necessarily matter. Those are just numbers, and with inflation and stuff like that, it really has to do with how it changes the end performance. So if you're playing a game for like esports, so I know we have several people in computer science who play esports, and one of the big things with esports is fairness, right? You want to make sure that if you're the more skilled player, that comes through, and the performance of your computer or your internet connection is not the thing that's hurting, your gameplay or something like that. Well, now even among console gaming, depending on the game, if you're on a PlayStation Pro instead of a normal one, you might have an advantage. Could happen, right? So I think they kind of maybe moved in the wrong direction there just to maybe do a money grab. But wouldn't be the first time companies did a money grab. Go ahead.
So most games aren't run using some kind of virtual machine, like as you said, Java code has to go to a virtual machine. Because it's general code, it's not.
Yeah. So the question he asked is, so most games don't run in a virtual machine. That's most games that people would play esports for would not run in a virtual machine.
Yeah, like
Angry Birds can run in a virtual machine. So many games that have become very popular certainly could run in Java, no problem. But anything where you see lots of explosions and real-time stuff is not running in a virtual machine, or it's running at 7 frames a second. One of those two. Okay, so it took me down the applet thing. So applets were kind of a big deal because it allowed you to launch real deal applications out of a web page. The applet just launched the Java program. It just kind of started by clicking a thing on a web page. Kind of a cool thing. So Java's platform independence for the right purposes was its bread and butter. It still is today. Java's good for that, but it's not the right language for everything. From a programming perspective, Java is very much a string-based language. If you can get something into a string format, you can do anything you want with it in Java. It's as far as languages I've messed with, strings are most malleable in Java. Interestingly enough, I have found one of the hardest languages to deal with strings in is one of the newest languages, Swift. Swift is not friendly to strings, which is shocking to me, but whatever. But the other thing from a computer programmer perspective is Java's documentation is superior than any of the other mainstream programming languages. You've already seen with C++, for example, since there's 30 different versions of C++ over the decades, you have some documentation that's a little bit aged or, whatever that's been replaced. .NET, so C# stuff and things like that tends to be strewn about. There's not kind of like this one really good go-to place, or at the very least, Microsoft's documentation for it is not well organized. Java's documentation is the way documentation should be. And we're going to see that through experience as we go through here. Okay. Roundabout. It came back to, but that is all good stuff. I'm not going to be testing you on the history of Apple processors and stuff, but it is something for computer scientists to consider when we think about the different languages, because even though I say programming is programming, the language doesn't matter, there is still the idea of using the right tool for the job. right? Java's not.
थोड़ी ठंड लग गई शायद।
Go ahead.
यस चालू हो जा मैम।
I don't speak that language. What's I'm guessing it was a phone call and he wasn't muted. I'm also guessing that was Telugu. So I actually speak a little bit of that language. Mostly the bad words, but go ahead.
Apple like make a computer, I think back in the 90s or 80s or something that was that almost had like the downfall on them or something.
It wasn't that Apple made the computer. So the question was, didn't Apple make a computer in the 90s that was almost their downfall? So I mean, we'll keep going down the path. It's fine. You might miss your homework assignment, but we'll see.
We're ready for it.
Yeah. When we say Apple is proprietary, how many of you think that is a negative thing? Proprietariness sounds negative, right? Proprietariness sounds negative. Proprietariness is Apple's secret sauce. When Apple almost failed as a company, it's when they allowed other hardware makers to make Apple clones. This was back during the PowerPC days, PowerPC processors. So before they switched to Intel and then switched back, yada, yada, yada. So they allowed other places to make PowerPC clones, Mac clones, which then took money away from Apple. Also historically, when, I think all these big companies, I would argue, are pretty unethical. So let's not pull any of them up for any sort of ethics prize or whatever. But I think companies like Microsoft actually get maybe in some cases unfairly demonized. You have the Apple users who will say, "Oh, well, our operating system just works, and it doesn't do this. We don't get the blue screen of death, yada yada yada." Well, Apple's solving a much, much, much easier problem than Microsoft is. Apple is writing software that runs on only their own hardware. Microsoft is writing software that runs on every piece of hardware, including Macs. So when you consider it like that, Windows is shockingly good. Shockingly good. If I were making bets on which computer crashes more often, my Mac or my PC at home, my PC at home crashes more often. But it doesn't crash often. Once in a blue moon, I reboot it twice a month or something like that, and it's pretty good. Probably needed software updates anyways. But yeah, that was the backstory to that. Is Apple started allowing other companies to make clones of their hardware, which then took money out of their pocket. And at the time, there was really nothing special about Apple software. It was really that everything was married together, and the perception was it just worked. I'd make the argument that prior to OS X, Mac operating systems were pretty crummy. They were not good operating systems. OS X is good, but they took it from OpenBSD, so at least I don't think it was stolen. I think they agreed, but at least they picked a good base operating system to take stuff from. We could also go the other route for folks who were in the early days of iPhone and Android, who would argue that Android was the better operating system over iOS. There is not a logical argument for early days of Android to say Android was anything better than junk. Android was based on the Linux operating system, which here's another example of how this idea of proprietariness. When I say Apple's proprietary, we think it's a bad thing, but it actually was their secret sauce, and they almost failed it as a company when they moved away from it. Early versions, if you looked at commercials from the early days of iPhone, what you would see is all of the Android commercials, like Samsung, things like that, they would point to, oh, Apple doesn't support multitasking. When your first iPhone, you could either have music playing or you could be checking your email. Couldn't do both. And people thought, oh, well, my Android phone can do two things at once. Why? Well, because they built Android on top of Linux because they were rushing to get to market because of the success of iPhone. Well, when you build your mobile operating system on top of a desktop operating system that has a great multitasking subsystem that assumes you're plugged into a wall, it sounds good on paper, but your battery life was 8 minutes. You know, there was all the jokes back in the early days where people were carrying car batteries and backpacks to keep their Android phone charged. Um, so Apple really had the right play there. Then Apple updated their operating system to allow like 8 different things you can do in the background on your phone. So it wasn't just open-ended multitasking, but hey, you want to play music in the background? We got a hook for that type thing. Now, so Android kind of moved back towards more controlled multitasking, and now they both have significantly more multitasking than they used to because our battery technology is so much better. But things don't always, you know, they don't always meet the eye when you there's more than meets the eyes. Transformers, right? To a lot of this stuff, there's a bigger story. I need to start wearing my Transformer shirts here.
Yeah, I mean, we haven't seen you in it yet.
I know. I got a really cool Optimus Prime one.
Is it also a Hawaiian polo style?
It's similar, yeah. That one's really big because I used to wear 6Xs. You know, think I'm big now. I used to be over 450 pounds. So I've lost like 130 pounds. So I don't know, my 6Xs are a little baggy. I think this one's probably a 4X and it's pretty baggy on me, but I make it look so good, so it's probably worth it. I'll bring Optimus Prime in soon. Back to documentation. So, what were we talking about? All right. So the idea here, just to get us back around the loop here, object-oriented languages are organized in a hierarchy. Okay, all of them are. So in Java, the top of the hierarchy is this class called object. And when you look at where it lives at the top level of Java language. Java.lang is the package. That's the directory structure. So if we don't put public, private, protected in front of something, I said it has package level security. So if you were to look at the entire Java programming language, you'd have a folder called Java. Inside of that, you'd have a folder called lang. And then you'd have a class called object.java would be in there. All right. So these are the things, not a big list, right? But these are the summary methods of the things that an object can do. Every single object that exists in Java at some level comes from this guy. Now, if I just, let's just go up to, can I do an overview? Yeah, let's go into java.lang. I want to get to a, let's do buffered reader. All right, so this doesn't go that deep, but it's enough. So we have this class called buffered reader in Java, which allows you, this was before reading stuff in from the user, which now we use scanner, but in the early days you used input streams and this thing called a buffered reader. A buffered reader is a reader, which is an object. So we would say buffered reader extends reader. And if we were to go look at the reader class, we'd see that reader extends object, although we wouldn't actually see that extends object. That last little level that we looked at here, this guy is hidden from us. But it will work. I can run this code right now and it'll still work. That's legal. Okay, it just does, they don't make you write it. That's why I use older languages that in many cases would force you to do this. So you start seeing what's under the hood. All right. So going full circle here, we have this idea about hierarchy. And we would say that in this case, buffered reader inherits from reader, which inherits from object. So a buffer reader has everything in it that a reader has, which has everything in it that an object has. We do have some options to override things. We could inherit something from a parent and then we could tweak it if it made sense for us. So we can kind of get half of it. And we're going to see that here in an example. So we swing back through here. We said that, okay, well, a player, in order to build a player, we need a name. The constructor for player will do the rest for the genericness of a player. So when I'm writing a fighter and I say a fighter, and I say a fighter extends player, the very first thing I need to do is I need to call my parent's constructor to do the initial setup of my heritage, something like that. So I would say super and pass it the name. Super is how an object refers to its parent from within itself. Now, the call to the parent's constructor must be first in Java. Because if you think about this, if I didn't make it first, and I came in here and I say this dot name is equal to, I don't know, woot or something like that. If I just pretend like I ignore whatever was passed in here, and then I set the name to whatever I want. First of all, I wouldn't have access to this right now, right? What is name? Name is a string. That's private. Where can I access that guy? Only inside the class called player. But now I'm sitting in a class called fighter, so I wouldn't have access to this guy anyways. But if we pretend for a second that I did, it's not going to let you do other things that might break the parent's constructor. You call the parent's constructor first to do the initial setup, and then you can differentiate yourself from there. All right. So after this call to super name, after I call my parent's constructor, so super is my parent. So what that guy's doing is it's calling this constructor right there. After that line, my fighter is now at the very least a basic player. And I could choose to do nothing else here. I can go out to driver. I'm going to not fight right now just so we don't have a whole bunch of extra crap on the screen. I'm going to say fighter F is equal to new fighter Bob. Then we'll say F dot display. And we see that the constructor for fighter does nothing except call player's constructor. So as we have it right now, a fighter effectively is exactly like a player, just called a different name. So there's Bob. He's got all of the hit points and strength and armor class and all that stuff, even though we didn't write any of that inside of fighter. We instead leveraged our parent's constructor, player, who did all that stuff for us. Now notice here that out in driver, I was able to say, fighter, I want you to call your display method. If I look inside a fighter, do we see a display method in here? That's the entirety of my fighter class right there. Any display method? Nope. But we got the display method from our parent since we extended player. And the display method inside of player, first of all, is public. So we have access to it out everywhere, basically. And it does the player display stuff. All right. Now, we mentioned that if we were going to further differentiate a fighter from a player, what I'll go ahead and do here is I'm going to go ahead and say this dot display inside here. I could also say super dot display. They both mean the same thing in this particular case, because this dot display is calling the display method that I inherited from my parent, and it doesn't exist here. It actually is my parent's display method. So this dot display is the same thing as super dot display in this particular example. But I'll go ahead and internally in the constructor, I'll call the display method, but then I'll go ahead and say my strength is equal to my strength plus, let's just say 3. So we're going to say fighters are 3 units stronger than a general player. All right. Now, if I run this right now, So I call the constructor, calls its parents constructor. I display it. So at that point in time, it's going to be just a plain Jane player. Then I further differentiate myself from a plain Jane player. I attempt to further differentiate myself from a plain Jane player. Then I'll go ahead and call my f.display, showing my updated fighter that now should be 3 units stronger than the previous guy. Okay, but I'm going to get an error here. Why am I going to get an error? Still private.
That into
Okay, so right now we see that, oh, strength has private access in player. Okay, complain on both sides of the equal. You can't access them here, so you can't change them, and you can't access them here. You can't read from it either. So, question that was asked in here: does that mean we can do a getter? Well, you'd also need a setter since we want to change it. You could do that. You could do a getter and setter, but if we ask ourselves the question, should a fighter have direct access to their own strength? Seems reasonable, right? And because we're writing this inside of fighter, we would say that, well, I still want it to effectively behave as private from a fighter perspective, right? I'd like to be able to access it in player. I'd like to be able to access it in fighter, but I don't want other people to access it. So I'm situationally giving myself access based on, in this case, strength is accessible by the parent, and I want to make it accessible to its children. And that's where protected comes in. So if I go up here and I change strength to be protected, now that unlocks it so that it's also accessible to children of the player class. So there's our thing, and we'll see that Bob's strength is 14 here, which is 3 stronger than his baseline playerness. So here was Bob's strength before we updated his strength. This is immediately following the call to the parents constructor. So we see that he did have a strength of 11. That is this guy right here. Us calling the display function immediately after calling the parents constructor, but before we further modified strength. That's why we have a strength that is 3 larger here than it was here. Make some sense? Okay. Now, you mentioned for wizard, what differentiates a wizard from a standard player? Probably. Oh, we also said we might have a stronger armor class for a fighter. So let's go and update that as well. So I'm going to go ahead and dump this display function for now. Here, actually, what I'll do is I'll comment it out. So in case when you're doing your homework, you can go and if you want to reference it or whatever. So we're going to update the strength just by 3. You might decide you want to update it by a D4, update it, so it's somewhat random. So I guess we could do that. We could say something like dice D is equal, we'll call it D4. D4 is equal to new dice with 4 sides. And then we'll just update this by D.roll. So we'll roll a 4-sided die, get some number between 1 and 4, add that to our strength. Similarly, let's say this dot AC is equal to this dot AC plus maybe 2 times D.roll. Twice a 4-sided die, higher armor class, maybe, just to differentiate itself from strength. We'll have to tune our game to decide if this guy's even hittable. Right. But for right now, this is a reasonable enough thing because this dude's probably wearing plate armor. Okay, while we decided that the wizard's wearing a nightshirt. So it's gonna be a rough fight unless this guy's dropping bombs. All right, so that's our player for right now. So what differentiates a wizard from a normal player? Probably has lower strength. Let's see. Differentiated from player. We have lower strength, lower AC. Anything else a wizard might have? Go ahead.
I feel like you could technically give idea of like cells.
Yep. So most games, so you go back to old school Dungeons and Dragons, we usually had some number of spells per day you could cast of different level spells. That's been abstracted in our modern video games where typically magic casters have like a mana bar, that every spell costs some amount of magic power to cast. And if you run out of that, then you're poking people with sticks. I once had a Dungeons and Dragons campaign where I played a wizard that refused to use magic. It was philosophical, a philosophical difference. This was an old, predating Dungeons and Dragons, a tabletop game called Roll Master. So you had all these different crit tables, and one of them was called the Horned Tusk table. So whenever I had a crit or natural 20 with that guy, I would have to run on the Horned Tusk table to see how much damage I did with my stick with my magic user. But in the end, in our epic battle, I just dropped the fury. I finally got over my fear of magic and just rained it down. Uh, so, so we maybe would say that a wizard has mana, which is a currency used to cast spells. Something like that. Now, if you wanted to have kind of the equivalent of that over on the fighter side, so most of our games for your fighter type things, there's a secondary resource that fighters might have. World of Warcraft is called Rage, but it might be something else. So if I go to fighter, I might say that a fighter has a private int called Rage, okay, which is going to be some a resource, let's say. And what I'll do is I'll go ahead and I'll create another dice. Let's call this guy a D100. Post new dice with 100 sides. And I'll say this dot rage is equal to D100 dot roll. All right, so we've added this new ability to a fighter. So I'm kind of modeling our fighter like I want you to do for your wizard for the assignment. And then the very last thing here would be I would probably update. I'd override that display function. So even though I already got a display function from my parent, I would go ahead and I would say I have a public void display. And the very first thing this guy does is he goes ahead and calls the parent's version of display to get all the stuff that used to be there. Then he'll also do something like system.out.println. Rage, did I call it rage? Yeah. Rage is this dot rage. All right, so now when a fighter displays himself, he does everything that his parent did, which I think actually has the extra little asterisk there. So the rage will be below the asterisks. So out here in driver, when I create my fighter and then I tell it to display itself. Oh, private access. Give me a moment. Here's me updating strength and armor class here. I didn't make those protected in player. So just like I had to update strength, I need to do that for hit points. I need to do that for armor class, so I have access to it. We probably could also do it for name. Your fighter should probably know what his name is. Then I'll run this. And this was called D4.roll. Just want to make sure this is in a working state for you. Okay, but your homework will be to write the wizard class. So notice here that when a fighter called his display function, It was everything that his parents had, plus it showed his rage. A wizard, which is what you're going to do for your homework, has less strength, less armor class, but also has a currency called mana. So you should also write the display function for a wizard. So basically write wizard similarly to what we've just done for fighter. I'll give you this code as a starting point, but wizard's going to have lower strength, lower armor class, and instead of rage, it'll have mana. Make sense? You don't have to change the fighting or anything yet. We'll start doing that on Monday, but you can. You want to run, or Tuesday rather. If you want to run with it, you can. All right. Questions, comments, concerns, bribes. I know I have a question here in class. I'll answer it. I'll leave the recording going, but if you got to roll, you got to roll. We're already past class. Go ahead.
So is it Panic like MP or, SP?
Yeah, spell power, magic power. Yeah, same thing. I don't care what you do. Just give your. I mean, if you want to give your wizard 5 different things, that's fine. I don't care. I just want to see you explore inheritance. Yep.
Is it generally how game works?
Game like who? Oh, yeah. Pokemon would be a Pokemon would be a modern day spin on D&D and kind of a less medieval type thing, but yeah, same thing.
Maybe you were a D&D person.
Are you a D&D person?
Yeah. Yeah. Although I know someone who's been into that for many, many years.